Okay, hello everyone. Welcome back to Calculus 1000. How are you guys all doing? Good. Kind of. The voices doesn't sound like. Okay, I hope that things will go smoother and nicer, and I hope that you had a chance to relax a little bit this weekend. Today we are starting a new chapter, new section 3.1, and this is completely new topic. So, but we will use the what we have learned so far. Before the main topic starts, I was checking my notes. There is an example of horizontal asymptotes. I will do that example before we start actually what is differentiability, tangent line, and things like that. Is there any questions, any comments before I go ahead and write down things? Are we all feeling okay? Yeah? Okay. Then let's, maybe I would write it all the way. Ooh, that's me again, not raising boards. Can anyone remind us what, how did we find the horizontal asymptotes for a function? Can anyone remind us? I will write example. Yeah, horizontal asymptote. I give you a function, f of x equals to square root of x squared plus 3 over x minus 1, and say find horizontal asymptotes of the given function. What should we do? Yes. We should find limit as x approaches to both plus infinity and minus infinity, yes? And whichever gives you plus equivalent number, so limit at infinity, you get a number. That number, y equal to that number, is a horizontal asymptote, yes? Now, I have this example. Because we are going to start a new topic, I won't give you much time, but I want you to start working on that. Remember that whenever we get infinity over infinity, we factor out the dominant term from numerator, dominant term from the denominator, cancel it, and resolve that infinity over infinity problem. Yes? How about I give you 1 minute? This is just good example to remember what happened, and then I will do the example myself on the board. Go ahead, please. And feel free to talk to the person sitting next to you. That's the help that you can always use.
Actually, it's bigger than mine.
There are two limits. Limit as x approaches to plus infinity or negative infinity. I'll try to keep it in one limit until the moment we need to separate them, yes? So here, my function is square root of x squared plus 3 over x minus 1, yeah? And a very simple observation here. As x approaches to infinity, this is a linear function. It will go either to plus infinity or minus infinity, yeah? This guy here is a quadratic, and it will grow bigger and bigger. If you have a number which is growing big and big, you find the square root. The square root of that still will grow to bigger and bigger numbers. In other words, this guy here, in some sense, is infinity over infinity. It could be infinity over negative infinity. It doesn't matter, but that's the indeterminate form. And when we got the indeterminate form infinity over infinity, what did we do? Yes?
Back out the dominant factor. So
The dominant factor in this case is?
x squared for the bottom.
So I will factor out x squared. Then here I get 1 plus 3 over x squared. In the denominator, I get okay. Well, just to be safe, look, if I can cancel it, the next step is cancel, yes? The term that causes the infinity over infinity we want to cancel. If I cancel it in some ways, I see that the remaining part is easy to deal with. So I can basically turn this into two limits. The reason that the second part is easy to deal with is the fact that 1 over x and 3 over x squared, as x goes to infinity, these guys are going to be 0. So I can use limit laws. Quotient law will work here. I get root 1 plus 0 over 1 minus 0. So that part is easy to calculate. What remains is this piece. Now, I need to cancel. I want to figure out, is the square root of x squared the same thing as x or not? What is square root of x squared? Louder, louder, louder. What is square root of x squared? Okay, I hear that there's x plus minus x, which I don't know which one to use. Yeah? But the rest all are saying x. Yes? Can I hear again? What is the square root of x squared?
Absolute value.
Huh. All those who are saying x, there is a problem there. And I will show you just with a simple example. Negative 2 squared is? No, louder. 4. Okay. Now, if I find the square root of that, what is square root of 4?
Plus or minus.
Come on. Square root is always positive. When you're trying to solve an equation, x squared equal to 4, you say plus square root of 4 or minus square root of 4. So in this case, yeah, we started with
Negative.
we got, definitely we didn't get the same thing. So what you said, this is a wrong statement. But it's easy to fix, and that's the level you have to be worried. If it is negative thing squared, then positive of that will come out. If you want to take home something today and say, I learned something, I can go to bed and sleep nicely, that's what you have to take with you home. Square root of x squared is not x, it is absolute value of x. There was a question in the quiz 1 or 2. You were trying to solve sine squared is less than something. And I saw that there were lots of students saying that square root of sine squared is sine x. which is not. It's absolute value of sine x. And that's where some of the problems came out. OK, now, so then I can replace this by absolute value of x. OK, I cannot simplify absolute value of x with x, but I can separate it into two pieces. When x approaches to negative infinity, when x approaches to positive infinity. Why? Because when I'm going to positive infinity, I'm using only positive numbers. Absolute value of a positive number is that number itself. So absolute value of x over x will become x over x. And the other part doesn't matter which limit you take. It will be root of 1 plus 0 over 1 minus 0. When I'm approaching, oh, wait a minute. That was supposed to be, OK, negative infinity. OK, what's absolute value of a negative number? To get it positive, I have to multiply it by a negative sign. Sorry. This is what you will get, yes? So absolute value, when you're working with negative numbers, it comes out as negative x. When it goes to positive, this is what you get. And well, now I cancel. I get negative 1 times 1, which is negative 1. This one I get 1 times 1, which is 1. So the function has two horizontal asymptotes. Y equal to negative 1 and y equal to 1. I wanted to make sure that we go over this. This is a very calculationally very important example. And I wanted to make sure that we do see this example. Any questions, any comments? Square root of x squared is? Louder. Square root of x squared is? Absolute value of the x. That's the lesson of the day, maybe. OK? So, I will erase this part to start. There are two concepts before we start differentiability, which kind of saves us, which kind of tells us what is the historical story behind derivative. One of that is the tangent line. Let's say I have a function, the graph is given like that at point A. Well, I evaluate and I get this point. Yeah? I want to find a line which crosses from that point, but it touches the graph very gently. It is tangent to the graph. Something like that. To find an equation or to describe a line, including tangent line, I need to know two things in different format. One is that we need to know slope. Yeah. In this case, I don't know yet what it is. The other thing, I need 1 point on the tangent line. I know 1 point because the tangent line should be tangent to the graph of the function at that point. Yes? So I know that there is a point. I need to find the tangent line. But since we are crossing, we are tangent to the graph, I don't have any other thing. Remember that in general, if I have two lines, I have a line. I can pick 2 points on it. And then we can use those 2-point components to find the slope. Can anyone remind us how did we find the slope if we had these 2 points? Yes, please. Yes? y2, yes, minus y1 over x2 minus x1, yes? Or you say it better than I can. You call it what? Rise over run? Yes, rise is what the difference of y values are. Run is what's the difference of x values. I want to repeat the same argument there. However, I don't have 2 points on the line yet. What I can do, then this is the power of limits. I can say, forget the tangent line. Draw a line which crosses the graph at A if A and at A plus H and F at A plus H. In other words, I just walk away from A, H unit, and then create another point. Obviously, this line is not tangent line. It's not tangent. It's very harsh, cutting the graph. It's very hard. We call these ones secant lines. Secant line through those 2 points. A f at A plus H, F at A plus H. Okay, if I do that, then I can find the slope of the secant line. I'll denote it by m of secant, yes? I have 2 points. Rise would be F A plus H minus F at A. Run will be A plus H minus A. Or in other words, I will get F at A plus H minus F at A divided by H. Yeah? So that is the secant. But how is it going to be related to the tangent line? The idea is tangent line is limit of secant lines. In other words, if I move this point closer and closer to A, for example, I can go there and I try to, okay, that's another tangent line. How about I go here? That's another tangent line. I get closer. That's another tangent line. And I try to shift this other point closer and closer to A. In other words, I'm trying let H to go to 0. The H unit from the original point. Now I want to decrease that distance as much as I can. And that is how I will get the slope of the tangent line is nothing but limit of the slope of secant line as H goes to 0. Or you like it to write it complete, F at A plus H minus F at A divided by H as H goes to 0. That will give me the slope of the tangent line. And this is possible for us to do because now we have a meaningful way of calculating limits. And well, this is nothing but that limit. Let's see this in an example. Let's see this in an example. Find an equation for the tangent line to the graph of f of x, I think was it x squared minus x, at what point? At point 1 and 0. At point 1 and 0. So the first thing to check is that, is this point on the graph, if I plug in x equal to 1, what is f at 1? What is f at 1?
0.
What is f at 1? 0. So yes, this is a point on the graph of the function. So we are actually looking, we have a similar situation. What should I do? I should find the slope of tangent line by finding limit of slope of secant line. What was the secant line? Tangent of secant line, sorry, slope of secant line. F at a plus h minus f at 1 divided by h as h goes to 0. That is the definition, basically, yes? Should I give you 45 seconds to do that calculation yourself? First thing is plug in those 1 plus h1 into your equation, into your function. Find what is the quotient that you're trying to find limit for, and see if you can evaluate that. 45 seconds, start the work, start doing it, evaluate each term, and then go ahead. 45 seconds starts now. Seconds left. F at x is x squared minus x. So f at 1 plus h will be 1 plus h squared minus 1 plus h minus f at 1, 1 squared minus 1 divided by h. Okay, that part is 0. Let's simplify this first part. So the first part, a plus b squared is a squared plus 2ab plus b squared. Then we have minus 1 minus h. That part is 0, so I don't need to write that. And look, this cancels with that. I actually can write this here just to have a simpler thing. So h squared, and 2h minus h gives me see, so far I haven't simplified, I haven't evaluated limit. I was just trying to simplify the function whose limit I'm interested in, and then I got to this point. And when you want to evaluate that, what kind of situation you're running into? Yes?
Divide by 0.
Okay, then what do?
You have to factor and cancel.
You have to check the numerator, and you get into 0 over 0. 0 over 0 indeterminate form. Remember that I told you the useful limits most of the time will come to that 0 over 0, and that's one of the important reasons. And when you have 0 over 0, you do factor cancel, yes? In this case, the vanishing factor is h, and this cancel, then limit of h plus 1, h goes to 0, I'm sorry, it's so low there, and then you do sum law, which gives me 0 plus 1, or direct, direct substitution, yes? 1. So the slope of the tangent line, based on the work we showed, is equal to 1. I have a point, 1, 0. I have the slope. How can I write the equation? Well, I think you guys know way more than I can tell you there. I love to use this formula and then simplify as much as I can, okay? In this case, y1 is 0, so y minus 0 equals m is 1, x minus 1. In other words, we have y equals to x minus 1. That's the equation, or an equation for the tangent line to the graph of this function at x equal to 1. Any questions, any comments for me? Yes, please.
We're on the right. How did you go from ones to x's?
Sorry, from where? Could you?
The first step and then to the second one. How did you go from ones in the numerator to x's?
From this to that? I'm expanding this. A plus b is a squared, 1 squared. 2 times ab, 2 times 1 times h, 2h, plus b squared. Yeah? So this is the expansion of that guy over there.
It's not x, it's 1 plus a.
May, oh, do you see these ones as x's? Now bigger x's, yes. No, those were ones. We canceled the ones there. Yeah. Any other questions? Any other comments? Okay. So that's one concept that you should know for this part. There's also another concept which is related to the derivative. This is called rate of change. When you have a function, f is a function on the given interval AB. Okay? You want to see how this function changes on this interval. Well, then you come say that, okay, I can see what happens at that end point minus at the starting point. Yeah? That's how the value of the function changes. But you want to turn it into rate. In other words, you want to see how the values of function changes per unit of change in x values. So you divide the change of y values by change of x values. You get that number, the change of y values divided by change of that. Now we call this rate, or more precise, average rate of change of f on the interval AB. So you try to find this ratio. It's important ratio for this function. This is like if I'm driving from here somewhere, and after 10 minutes, someone is trying to see what's the average rate of change of me walking or driving. In other words, average velocity is there. But as I'm moving my car, at each second, it shows some number. That's my speed, yes? What is that? It is not about, that one is not about the average. It's about what is happening right now in this instant. And that's why we have another thing, which called either just rate of change of f at a, or sometimes you will see me writing instantaneous, oh my God, didn't fit there. Instantaneous rate of change, or just rate of change of function at that point. I'm trying to see what is my speedometer or odometer in my car showing. That guy is not just the average, it's limit of average. What you do is that you say that I want to find the average rate of change on that interval. So I get this thing over this. But then I want to make that x as small as possible. So I want to make that interval as small as possible. In other words, let x get closer and closer to that point A that I started. And that will give me this limit. Average rate of change is defined for function on an interval. Instantaneous rate of change, or sometimes I'll call it simply rate of change of function, is defined at a given point. And this is how it is defined. Before I move and do an example there, I want you to think about these two concepts. There is a limit here, which gave us the slope of tangent line. There is another limit here. Now, you're getting 40 seconds. You're not trying to think for yourself. You're talking to a person sitting next to you. And you're trying to come up with an argument that says this limit and that limit are going to be the same thing. 45 seconds for you to think about with your friend, talk to your friend about why this limit and that limit are the same things. Go ahead, please, 45 seconds. I don't want to see anyone sitting and doing nothing. You need to talk to someone. You need to talk to someone. Oh, no, I don't want to delete that. Ten seconds. Okay, that's done. I loved how noisy was that. I hope that you were talking about those limits, not about the rest and what was the media, social media that you guys use these days? Oh, Instagram. Hopefully it was not about the Instagram post. Okay, I need one team of two, one pair of partners, to tell us if you figured out why they are the same, or how you argue they are the same. Can I see if I can find someone else? Okay, let me see. I want to find another person. I'm getting so many answers from these two. Yes, please, loud, please.
In general terms, going from A to B is the same thing as the difference between A and B going to 0.
What is representing the difference there? H. Okay. So if we let A plus H to be X, to be more precise, yes? So the idea is that the difference of A plus H and A is H, and we can take X to be the other point rather than the difference one. This will give me the chance to change my H limit to X limit. What do I mean? I want to change everything written in terms of H and write them in terms of X. So A plus H is X, I already said. There is no H in this part. How can I write H in terms of A? Yeah? How can I do that? The answer already given there, but that's basically this algebra, simple algebra. Take this to the other side. H is equal to X minus A. Now, I don't have any H there, so it doesn't make sense to write H goes to 0. I have to write something in terms of X. Yeah. Yes? So if H goes to 0, that means that X minus A goes to 0. Yeah? That's how. Or in other words, we can say X goes to A. Those are all equivalent way of saying the same thing. Those two limits are exactly same limits. They are not different things. So one can use that or the other one. But the terminology is what you have to know, and you have to know how to use it. Is there any question before I write the next example down and we do? Okay, let the function, let f be x plus 3. Part 1, find average rate of change of f. I have to write on an interval from 1 to 6. Part 2, find. If I don't write instantaneous, it still means instantaneous, yes? So find the rate of change of f at x equal to 1. You know what you're supposed to do. Write down, start with the formulas, patiently write down what are the starting point, and then evaluate both of those ones. I'll give you 90 seconds. This time, if you need help, you can talk to the person sitting next to you, but my expectation is at this point, you can take these two formulas and use it in that specific F case, what is A, and so on. Go ahead, 90 seconds starts now. 40 seconds left. Average rate of change on an interval. You're trying to find f at end point minus f at the starting point divided by the difference of x's, yes? And in this case, we get root 6 plus 3 minus root 1 plus 3 divided by 5. Root 9, 3 minus root 4, 2. 3 minus 2, 1. So this is 1 over 5. So the average rate of change on that interval is 1 over 5. How about the rate of change? So this is going to be given by this limit, yes? Just note that at a, for a, I plugged in 1, yes? Now I want to evaluate this. Root of x plus 3 minus f at 1 is root 4, and this is x minus 1 as x approaches to 1. And this gives me limit of root x plus 3 minus root 4 is 2. So, okay? And then you try to use quotient law, but then the limit of the denominator is 0. You find limit of numerator. It is indeterminate 0 over 0 case, yes? And I have to resolve it. Wait, why do I have that long square root? I think this was not supposed to be there. This was for that one. Huh. If I tried hard, I wouldn't be able to do it myself intentionally. Okay. To resolve 0 over 0, we have to factor, cancel. How do I factor in this case? Yes?
With a conjugate first.
You have to turn it into a polynomial by multiplying it by its conjugate. So in this case, in other words, it means x plus 3 minus 2, I multiply it by x plus 3 plus 2. And then I have to divide the whole thing by that as well so that I get easier term. And this will give me, this is squared minus 2 squared. And here, I write whatever I had before. What is the square of square root of x plus 3?
The value of x plus 3.
I got you again. If it is boxes squared, then it's square root. You get absolute value of box. Why? Because that box could be positive or negative. But when I say square root of box, it means it's already positive. That this makes sense. Square. That one is a box itself. Because to start with, that box must have been must have been positive. I didn't need to put absolute value there. This guy, this box doesn't need to be positive. I have to put box absolute value because of the reason we discussed, yes? Just keep in mind that one. This one is not very complicated one, but what you will get here is that x plus 3 minus 4, which gives me x minus 1. So we factored, cancel that with that. Do the work that you need there. Plug in here. I'll write like that, dot, dot, dot. In the numerator, you get 1. In the denominator, you get root of 4 plus 2, which is 2 plus 2, and you get 1 over 4. So the instantaneous rate of change of that function at x equal to 1 is 1 over 4. Any questions, any comments? Any questions, any comments? Okay. We have done very good work to get two things done. You have to know the terminology. You have to obviously be able to carry out calculation like this. But these were just historical examples of what made mathematicians to think about maybe this limit by itself is important to consider. And that's where we get the definition of the day. Let f be a function. Let f be a function defined at x equal to a and around it. So we need to make sure that it is defined at a and it is defined around that value. Then we say f is differentiable at x equal to a if the limit, what limit? This limit that we have been working with, limit of f of x minus f at a over x minus a as x approaches to a. Or equivalently, limit of f at a plus h minus f at a divided by h goes to 0. If this limit or equivalent version of that exists, if that limit exists, we call the function differentiable at that given point. If the value is L, if this value is equal to L, then we write it f prime at a is equal to L. So we want to have a notation, clean notation for it. I don't want to write always this limited thing. If that exists at that point, instead of writing the whole limit, we will use this notation, f prime at a is equal to L. Now, based on the examples we have done, we have shown one, f of x. This is the example behind this board, the first example that we did. I mean, the first, the tangent line slope that we did. F is differentiable at 1, and what was f prime at 1? Do you remember that? You don't remember it? It's just here. It's equal to 1. The second one is f at x equal to square root of x plus 3 is differentiable at, again, x equal to 1. And what was f prime at 1 in this case? What was f prime at 1 in this case? 1 over 4. The other instructor is in, so I have to stop here. Next time you come back, we will do more examples, and my main goal would be to show you a bit more about this. For example, what are the cases the function is not differentiable at that point? And we will start going over differentiation rules. If someone wants to review it, this is the time. I will go very fast on those cases. We will go over the differentiation rules very fast. We will do some examples, but make sure that you review before come to the class.